All right, Art22, welcome back. I'm excited about these next two lectures because they're, I think, the first kind of taste of some more interesting, maybe organic types of behavior that we're going to start to see from our code. We're still talking about movement and how we can make things move around, but today we're going to be using two different strategies to make, in this lecture we're doing one strategy, and then next lecture the other strategy of how to have motion that is maybe less predictable, more organic, more interesting, more complex than just either straight lines or lines with some acceleration, kind of like gravity, like we've seen before. So first one that we're going to do is the one for today's lecture, which is called, it's kind of a classic in the computer science world. It's called a random walk algorithm. So we're going to make something move according to this thing called a random walk. All right, so what is a random walk? The way I like to think about it is imagine a chessboard or checkers. You can choose your preference. So here we go. Here's our I'm going to go with chess. Here's our chessboard. Although kind of a weird chessboard because it's not going to be the correct number of columns and rows, but whatever. Okay, here's our chessboard. Let's say that our piece, which, you know, in this metaphor will end up being our geometry, but let's imagine it's our chess piece. It's starting off right here at that, in that box. Now, what we're going to say is our chess piece can move in any of the four directions, up, down, left, or right, by a certain step size. So let's say that it's kind of like a pawn, if you're familiar with chess, where it can only move one box at a time. So every single update of our piece, it can only move by one box in any of the four directions. So it starts here. Maybe it first goes up by one. Now maybe it randomly decides to go right by one, and then perhaps down by one. Now maybe it goes back up by one, and then right by one. So this right here is what we call a random walk. Now it wasn't quite random because I was just deciding which direction, but we're going to see that we're going to make our processing sketch use the random function to really make this random. So this notion of having some object, we'll probably have like a point or an ellipse or something, and it can move in any four directions. It has a step size. In this case, the step size was 1, and the direction was picked randomly. So let's see. So an example of this where we have a bigger step size. So let's go back to our chessboard here. Now let's say we started our new piece here at that cell. Now let's say we had a step size of 2 instead of 1. So now maybe the first step is 1, 2, we're over here. Now maybe we go up 1, 2, there. Now we go left 1, 2. So what we can see is we're still getting a very similar type of behavior. We're just covering more distance with each step in time because the step size is bigger. We can move more boxes in the same step. So this is all going to translate into pixels, right? Instead of a chessboard with a chess piece, we're going to have some 2D primitive and pixels. So what we're going to do today is build a random walk sketch. And we're going to do it with just a point, a 2D primitive called a point. And at the end, we're actually going to make 2 of them. And we're going to give them slightly different parameters, let's say. And I think it'll be a cool example of maybe the first like truly generative type of art that we've made in this class. And so I think it's fun to watch. It's very satisfying to see it when it's all said and done. So let's jump in and get our random walk all set up. All right, here we go. Okay, so here we have our week 3 class 2A sketch. And let's just go ahead and do all the normal things, right? We're going to have a setup function with our size and 600 by 600. Again, I just kind of picked that arbitrarily, totally up to you. We're definitely going to want a draw as well. Now, okay. So we know before we even get into any of the movement stuff and any of the random walking stuff that we're going to end up having a 2D primitive moving around. So let's get that set up first. So I'm going to use a point, which is a 2D primitive that we've seen before. And the nice thing about points is that they just take an x and a y. We control the size of them with stroke weight and the color with stroke, but we just need an x and a y. So why don't we say that we're going to have two variables. And now I mentioned that we're going to have two random walkers by the end of class. So I'm going to go ahead and set that up by saying, how about x0 and y0? Because we're also going to have a x1 and y1 later. Well, we're getting some errors. That's because we actually need those variables. So why don't we go to the top here, and I'm going to say float x0, y0. Great. And we need some initial values for these. Fun fact, if we weren't to set any initial value, the default is it would make it 0, but we want them to start in the middle, or at least I do. And so I'm going to say x0 is width divided by 2, and y0 is height divided by 2. We've seen that before. Okay. So we'll say position of first point, because we're going to have a second one later. And okay, so now let's get a few more parameters here for our first point. We need a stroke color. So I'm going to go with white. Oops. And I want a stroke weight, so how big? Maybe I'll go with 10. Okay. And might as well give a background too, right? So let's do a background of, I think I've managed to find a nice color, 108. Okay. So let's just make sure we're seeing our particle here. Yep. It's tiny. I was going to say, why is it tiny? Because I wrote stroke twice. I meant to say stroke weight. There we go. Cool. Okay. So this is size of point, color of point, draw point. Good point. Okay. All right. So we have our 2D primitive that we're going to have be moving in a random walking situation. So let's think about the aspects of the random walk that we were just drawing together. So we know that there are, there's a random aspect of this, right? Because we don't know exactly which direction it's going to go, up, down, or left or right. And there's also a step size component of this. You know, is it moving by 1 pixel each time, or is it moving by more than 1 pixel? So let's go ahead and make, let's decide that. Let's decide how big our step size is going to be with a variable. So I'm going to say float step size. And yeah, let's just keep it like that for now. Now, what will our step size be? Why don't we initially say our step size is going to equal, how about 3? So it's move every time, every step of time. So basically every time our draw loop goes around, we're going to move 3 pixels. That's the size of our step. Now we don't know which direction yet, but we know we're going to move 3 pixels at a time. Okay, great. All right, so now we need to actually use our step size in this whole idea of random walks and moving it in a random direction. Now, if you remember, when we, in previous lectures, wanted to move something, we needed to add some number to its position. So something like, if we were to have, we're using x0 as our number. So like, x0 plus plus is moving something to the right by 1 pixel, because that plus plus, remember, is adding 1. So we're saying x0, add 1, add 1, add 1, and it goes all the way off to the right. So we're going to still be using that idea to change the location by adding some number. But what we need to do is find a way to have a random number that is going to give the option for going in both directions. So for x, left or right, and for y, up or down. So the way we can do that is using processing's random function. So check this out. We're going to go x0. So let's deal with the x direction first. So left and right. x0 is going to be equal to itself plus, and here's the fun part, a random number between negative step size and step size. All right, so let's think about what this is right now. So we know that step size is 3. So this is basically like saying -3 to 3. What is that going to give us as a result? So that means that every frame of our imagination, of our animation, we are adding to x0 some number between -3, in this case, negative step size, and step size. So that means the options here are like, we could move -3, -2, -1, 0. There's an option we could now move, right? 1 or 2. Again, because remember, we don't include this number, we go up until it. So if you really wanted it to be the same, you could say something like step size plus 1. But let's just keep it kind of clear at the moment. So we're basically saying every frame of the animation, add a number that's a random number between negative step size and positive step size. So step size here is kind of constraining how much movement we could get. You could imagine if step size was 1, the only options we'd have would be -1, 0, and then up until +1. And remember, these are floats. Random gives us floats. So we're getting things like -0.5, -0.7, +0.8, all these things. So we're still going to get both directions, but it's going to be pretty limited to between -1 and +1. The bigger we make our step size, the bigger the steps could be. So let's just see what we're at right now. I'm going to keep it at 1, so very small step size, and let's see what we get. Okay, so it's kind of jittering here, but you can see that we're getting a little bit of left and right motion because every frame of our animation, we're adding some number between -1 and +1. So, sometimes it moves a little bit more, so maybe that's like -0.9. Maybe it barely moves because it's like, 0.001 or something like that. But we're starting to get this idea of randomized movement. The only problem is right now we're only in one direction, left or right. So let's go ahead and add our up and down direction, our vertical direction with y. Okay, so this can all stay the same. But what we need to do now is say y0 is equal to y0 plus random, and again, negative step size to positive step size. All right, let's take a look at that. All right, so now this thing is moving in both directions, albeit very, minimally, because our step size is only set to 1. So let's make that a little bit bigger. Let's change our step size to something a bit more interesting, maybe like 5. All right, there we go. Now we're getting some movement. So now we have a true random walker here that's, kind of buzzing around in a randomized direction within some range of step sizes. Okay. So what I want to do is two things. First, I want to set up a conditional statement to make sure that when this goes off the screen, it doesn't get lost forever, like it just did. So we've done this before, actually. I want to set up a conditional statement that says if our point has gone off the screen in any of the directions, we're going to reset it to some random location. So let's get that set up here. So what I'm going to do is I'm going to come down to the bottom of my draw loop. And, we've done this before, but let's just do it again together. So we're going to say if x0, so we need to check some things about x0. So we need to know if it's greater than width, so if it's off the screen to the right, or if it's less than 0, which means it's off the screen to the left, then what do we want to do? We just want to set it to a random location. So then x0 is going to be equal to a random location between 0 and width. So the full range of left to right of our screen. Cool. I'm just going to put in one comment here, just because we've done this before. Reset location if we go off the screen. Okay, cool. Now we need to do this for y as well, right? So I'm going to copy that. And let's just change these to y's. Y. And then we need to now not do width, right? Because we're dealing with up and down or vertical direction. So we need to do height and height. All right. I'm going to increase our step size a bit. And now we'll be able to see that this should reset if we do go off the screen. Now we wait. We are at the mercy of processing's random function. This might have been a great time to have some mouse interaction. Oh, you can do it. Come on, particle. Yeah, there we go. Okay, good, that works. Whew, what a journey. Here we are. So, good news, our boundary conditions work. There we go. Great. Now, two more things we're going to do with this today. One, we're going to make a second one, just so we can have a little bit of like a pas de trois, a little dance of, no, pas de deux, of our particles. Two of them going together, which I think ends up having a cool effect. And the other thing we're going to do is see how we can control the overall movement a little bit better. So let's start with that part. Let's start with controlling this a little bit better. So one thing we can do is instead of just having one step size that is for both directions, we can have separate step sizes for the x direction and for the y direction. And let's see what that's going to give us. So I'm going to say step size x and step size y. Now what this is going to let us do is have more or less motion along whichever direction we want. So let's say that I would rather have more direction in the, or more movement in the horizontal direction and less movement in the vertical direction. So kind of keeping things more like this, if you can see my mouse, and less kind of all over the place. So what we could do for that is keep our step size X relatively big, 7, but let's constrain our step size Y to be something smaller, like 2. So in X, we could get all the way up to -7 or 7 for each step, but we can only get from -2 to 2 for our Y steps. And so now we just need to change these accordingly. So X, X, Y, Y. Right, so we'll say add a random step to the X direction. Add a random step to the Y direction. Okay, great. So let's just take a look at what we get there. Yeah, so we're still getting both dimensions, X and Y, but we're living more, left to right than we are up and down. We're not getting as much movement up and down. So this is just a nice way to constrain things. If you want to put a little, if you don't want it to be totally random, you want to have a little bit of control, you can kind of tweak these step sizes towards whatever you want to do. Okay. All right, so here we go. We need this little guy, this little point needs a dance partner here. So what I'm going to do is, and we're going to see later that there's more efficient ways to do this, but we're going to do this, basically just going to make a copy of everything. So we're going to say X0, Y0, X1, Y1. We can keep the same step sizes. We'll just keep those the same. Now, I'm going to say, here's a little bit of a fancy trick. Let's say I want X1 and X0 and X1 to both start at width divided by 2. We can do this little fancy bit of magic. So X0 and X1 will both equal width divided by 2. Same thing for Y. Height divided by 2. Okay, we're going to keep our step sizes the same. So now what we need to do, so this is draw point 0. Okay, and now we need, draw point 1. So let's draw the other one. So what I'm going to do is just copy this entire thing. This would probably be a great opportunity to make some tabs and functions, but for today, let's just keep it like this. Now let's just make a few changes. First of all the zeros can become 1s. You could do like a control find and replace if you wanted, but I'm just going to keep doing it this way just for clarity's sake. So all the zeros are now 1s because we're using our other point. Step size can stay the same because they're going to have the same possible steps for both points. And now we just need to change this to 1, 1, 1, oops, 1, 1, 1. Aha, okie dokie. Now, let's just differentiate them a little bit too. This one was white, let's make this one black, I guess. And we can keep them the same size. And yeah, so let's just see what we have right now. Okay, cool. So I don't know what it is about 2 things over 1, but it just is more interesting. So let's make it so that the white point has what it is like right now, which is more left and right motion. And let's have the other one be more up and down motion. So what I'm going to do, so what we could do is set up a whole separate step size X, step size Y for each point. I'm going to cheat a little bit and just switch which step sizes we're using. So if this gets confusing, feel free to create new variables, but basically what I'm saying is we know that X, step size X, is the bigger one. So I'm going to use the bigger one. I'm basically going to flip them. So X is going to get the smaller step size, and Y is going to get the bigger step size. This isn't hugely important. This is just for my own kind of curiosity, just to have, you know, the white one going more left and right, and the black one going more up and down. Okay. All right, final piece of business with this random walk, which is I find it particularly interesting to have to see all the previous positions like we've done before in our motion stuff. So I'm going to comment out the background, and I'm just going to draw the background in our setup. So we're drawing it once, but now we should see all of the locations of our points. Yeah, there we go. So now you can kind of see, like, this is our first sort of piece of generative digital art that I think has some complexity to it and has some almost like organic kind of behavior to it. You can imagine having a whole bunch of these points that are all different colors that form some really complex overlaps and things. I'm going to make one tweak to mine, which is I'm going to say that I'm going to put both step sizes to be the same. And I'm going to add a little bit of transparency to the white one. And how about to the black one as well? Okay. There we go. So that's kind of cool. Now we get a bit more blending because there's more transparency. And what's kind of cool, just to kind of step back, is that this is different every single time, right? Like every time we run this, we're going to get new random numbers. So I think that's one of the cool things about generative art and digital art and coding art, is that you could have the exact same code, right? And every time you run it, you're going to get a new result. And to me, that's something that's very exciting about creative coding and digital art. And I think you can imagine that this could you could take this in a lot of different directions, and it would be very, very interesting. So I think that's where we'll leave it today. When we come back, we're going to deal with one other type of interesting movement that involves something called Perlin noise. And that's a little bit more complex, but it has some really cool results. So we'll see what that looks like together. All right, thanks everyone. See you next time.